Thank you, Valentine. As always, it's a pleasure to be here. I get to talk about three of my favorite things, and that is AI, and blockchain, and Python. So let's get started. Some of you might know this plot. It's pretty famous these days. And it was actually published in 2001. And what it shows is that data is wildly powerful. I was doing AI research in the 90s, actually, for National Defense Canada. And I was given a data set. It had about 20,000 data points, I think 20, 30 dimensions. And I spent my summer, 2 summers in a row, actually, playing with this data set, trying to have a little bit better algorithm and so on. I was trying to improve the error rate from 35% to 30%, right? And it was supposed to be deployed, for these uses. But, if you're going from 35% to 30%, what does that mean? It means your model is still terrible, right? So, and you can do whatever you want. You can have the world's greatest model, but it just doesn't have enough information to build something interesting. And this was actually how a lot of AI worked for many, many years, was you would have a fixed data set, you would work with it, and you would compete with others for publishing and so on by improving, error rate by 0.1% here, or sorry, 1% here, 5% there, or maybe 20% learning and so on, like 20% faster. But most of it really wasn't usable because the errors were still 20 or 30%. And what you really need is errors of 5% or 1% or even less, depending on the application. So what's shown here is research out of Microsoft, Banco and Brill, where initially most people had been working on when they had 200,000 words to work with. And with those 200,000 words, there was all these different algorithms that were competing, and standard algorithms, right, like KNN and perceptrons, naive Bayes, this sort of thing. And they were all competing basically of error rates from anywhere from 17% to 25%, right? And 3 or 4, probably 20 publications just out of that. But what these researchers did, they said, okay, instead of changing the algorithm, let's change the data, let's have more data, and not just 2x more data, but 10x, 1,000x, 10,000x. And what happened was it showed that, as we all know now, it's a standard thing, the data was unreasonably effective. So when you actually went up to 1 billion words, then the error rates actually got 5%. And it didn't actually really matter which algorithm you had, they all improved. And in fact, which algorithm was better, it changed depending on the amount of data. So the answer, the summary of this is that data is unreasonably effective, and that's sort of a title from a 2005 paper by Peter Norvig and so on out of Google. And that was also 10 years ago, this paper from Google. And since that time, what has happened is the people who have the data and the AI expertise are making fortunes, most notably Google, who saw it long ago, and Amazon for recommendations, and more. More data, with the appropriate compute power, of course, too, leads to more accuracy, now that we have the models with the capacity, deep nets and so on, leads to higher click-through rates, more sales, et cetera, which leads to more money. So the race is on for more data. Now, let's frame this in the context of the elements of computing. I always love to go back to first principles. And the elements of computing are storage, processing, and communication. We all know this. And within that, in terms of a stack going on in the world of AI and machine learning, this is kind of standard stuff. It's boring, but I'm going to relate this later on to decentralization. So for storage, we've got things like file systems, HDFS, for holding these giant data lakes of data, S3 from major data blobs and so on. For databases, we've got large-scale distributed databases like MongoDB, Cassandra, and another 50 like that, right? For processing, we've got business logic from CPUs or elastic compute cloud and so on. But then also when we have really massive compute needs, that's when we're using things like GPUs from NVIDIA, or maybe the more recent Google tensor processing units, MapReduce and Spark as some of the software to help drive all of this, right? And the shades of gray, this is actually where you have, this is really the building blocks that the AI really needs. So there's less of a push for needing to run with EC2 because that's just going to be too expensive. And of course, to connect it all together, we have things like TCP/IP to connect the different networks and so on. But really, it's all about storing massive amounts of data on the file systems and the databases, which are storage, and then the processing with high-performance compute. So, we've made great progress. You'll see many, many amazing talks today and yesterday and tomorrow with PyData. But all is not well in the world of AI, as probably some of us know. One thing is data hoarding, right? If you're a startup in AI, where are you going to get the data from, right? And the big guys have tons of the data, lots of data. And you can get some as a startup, but you have to be really sneaky or smart or spend a lot of money. Also, a weak data history. There's this classic aphorism from computer science, garbage in, garbage out. Well, the same is true when you're training machine learning models, right? If you have terrible data coming in, maybe that's untrustworthy and so on, then you'll have terrible models. And data is expensive. It's hard to price. There's high friction on this. So there's a lot of challenges here, right? So recently, sort of in the last half a year, I've been asking myself, can decentralization help this? And so, a bit of history, I did AI from the mid-90s all the way up until about 3 years ago, 4 years ago, full time. And then I went basically full time into blockchain and decentralization. And I actually have to admit, I really missed AI, right? I love AI. I continue to run the ML meetup here with others. And so it was probably inevitable that I really try to merge these worlds. I was thinking about it just because I thought it was a cool thing to think about. But what I've come to realize is, oh my goodness, there's really a lot of things that we can do that mix AI and blockchain in a really powerful way that can actually help the world of AI. And to kind of give a bit of a baseline here, one of the key things is to unlock blockchain technology for AI, one of the prerequisites is scale. Just like we saw from the unreasonable effectiveness of data, you really needed scale. You needed a lot of data to get there. And this is very different. In the world of AI in the 90s, once again, I remember conversations with AI friends. They're like, yeah, we've connected the dots. We've showed that it's possible. Now all we need to do is scale it up, as if that was like the last 5% of the problem. And what we've learned since is it's not the last 5%, it's the first 99.9% of the problem, right? In fact, as we know, the deep learning models of today, they're not that different from the perceptrons of the late 50s, well, the nonlinear ones from the early 60s to be precise. It's not that different, right? We have better regularization and a few other nice tricks, but it's actually not that different. So the same thing here, though. So we really, to unlock blockchains for AI, scale is job one. And databases, of course, go back a long time. There's sort of a history of databases. Oracle was the first company to really successfully commercialize relational databases, SQL style, in the early 80s. And they became very successful. And then when websites took off, then MySQL came along and made it much easier for startups to have their own database, rather than having to spend $100,000 or $1 million on some Oracle deployment. Since that time, scale really started to matter for more and more companies. So the large-scale stuff that Google and others were doing started to filter down and be available to the startups of the world through things like MongoDB, Cassandra, and so on. And that's really, the trick there was distributed databases, right? It was the idea that you could spread the compute load or storage load across more than one physical resource, right? It was still centralized. There was still one entity controlling all of it, but it was actually spread. Now, there's a new type of blue ocean. Each of these steps was sort of blue ocean from the past, right? Going from relational databases to MySQL. It was de-emphasizing some of the things that cared before and adding new things that mattered, whether it's adding open sourceness with step 2, adding scale with step 3. And what blockchain technology does is it actually adds new features, new specs that are interesting. And in this case, it's really a couple. It's decentralized. That is, no single entity owns or controls it, right? And this has a lot of value. It really helps for politics. It helps for sharing and pooling data and so on, as we'll see. It also has this notion of assets, or these days people talk about tokens, right? So you can basically own a token if you have the private key to it, and that can be transferred around on this decentralized substrate, and that's very, very powerful. And that's things that have unlocked this ICO madness of today. So you can frame this in the blue ocean sense too then. Basically, there is the idea of a blue ocean database for blockchains. So just like we had big data, distributed databases, now we have decentralized databases or blockchain databases. And this is where I'm spending my time, BigChainDB and IPDB. And another way to think about this is, on the left here, we see a picture of a distributed database, MongoDB or Cassandra or whatever. And there's a whole bunch of clients on the top, right, using it. It could be 10,000 clients. But in terms of control, there's just one admin, right? One dude or female in some corner just running something. So it's centralized control. And the difference with blockchain databases is that you have a whole bunch of co-sysadmins. You could have 5, you could have 500, right? And if a few of them start acting maliciously, that's okay, right? And so that's really the core idea, and it actually unlocks a whole bunch of other things. So going back to the sort of stack of the elements of computing, I've talked about the ones that were important for AI. Here's actually what's happening in the world of decentralization and blockchain. These elements are all getting decentralized, one block at a time. So for storage, rather than just things like S3 and HDFS, we now have IPFS, the interplanetary file system, and Filecoin for the equivalent of S3 storage. We have Swarm. We have storage with a J, and so on. In terms of databases, that's where BigChainDB and IPDB come in. IPDB is the planetary network version of BigChainDB software. And we actually have storage of tokens, or call it eGold or eCash. And this is actually where things like Bitcoin and Zcash fit in. So there's sort of new categories that have emerged as well. In processing, business logic, the most famous out there is Ethereum. So if you might have heard the word smart contract, that's really basically code that runs on decentralized processing substrate specifically for business logic, right? So it's not smart, it's not really a contract, so it's decentralized processing. But it's a great label, right? It gets people's attention. What's emerging also is decentralized high-performance compute, right? And there are actually several emerging technologies, TrueBit, Golem, iExec. These are among the more famous. But what's also interesting, what we've been seeing, is that virtual machines can actually simply be handed around. You can actually treat VMs as assets, right? So you can actually have a database that remembers who's doing what, and then just have, and then pass around those VMs as assets. You can also simply do client-side compute, right? You could actually have computation running JavaScript in the browser or in Swift on iOS. So that's sort of the building blocks in the second part. And in the third part, for communications, this is really connecting networks. And history-wise, what's interesting about TCP/IP? Before TCP/IP, you had ARPANET, you had NSFNet, you had CSNet. Lots of universities and otherwise were creating all these networks that they weren't talking to each other. And that was a problem, right? And then along came Vint Cerf and Bob Kahn and just kind of, hanging out, doing their, Vint doing his PhD. And they did this thing to solve this problem that they called TCP/IP. They convinced everyone to speak that language of TCP/IP, and they managed to connect the networks. So then they had a network of networks, which is now called the internet, right? But the problem is it's sending around packets of data. But what if I have value that I want to spend around, right? You can double spend packets, it's okay. But I don't want someone double spending my Bitcoins or my Ether, right? Or my air miles. And so what's cool, there are now something like TCP/IP for value. So I can actually send Bitcoin from one network to the next to the next. And this is via a protocol called Interledger Protocol, ILP. There's another one that's emerging called Cosmos as well, so they're kind of competitive. What's also cool, you can actually go beyond not just connecting networks of value, but you can connect them of state. So think of it like you've got a smart contract running on Ethereum, but imagine if it wants to hop to another network that supports smart contracts. This is actually possible now, or it's actually coming down the pipe also via something called Polkadot, as well as technology called Eternity. So it's a couple competitive technologies. Think of it like a computer virus with its own Bitcoin wallet that can hop across different networks, okay? So this is all technology that is emerging now. This is actually not part of the broad discourse yet in the world of blockchain, but it will, right? So don't think of blockchain as one noun, one giant monolith that does all the things. It's actually a whole bunch of different pieces of the compute stack, and this is actually what's emerging. Of course, if you think about for AI, then once again, we care about storage and we care about compute, right? To handle this massive data. So for file systems, we've got things like IPFS Filecoin, and that's quite mature. That's why I bolded it. We've got databases like BigChainDB, IPDB, also quite mature. 1.0 actually is coming out on Monday. And then we have high performance compute. And the most mature stuff there is VMs and containers and so on, as well as simply client-side compute. And I will talk about some architectures later. So this is kind of where we're at. I've talked about the importance of data. I've talked about the stack that we have in the world of AI. I've talked about this emerging compute stack for decentralization. But you might ask why? Why does this affect me? How does this help me? And this is what I'm going to get to, sort of hinting at these problems I mentioned before. I started giving a talk similar to this about 9 months ago, and at the time there was only a handful of things out there that were getting deployed at all. Now there's actually probably dozens of applications that are connecting AI and blockchain. And so I'm going to, now I have the luxury of actually picking and choosing the super interesting applications that combine AI and blockchain, and that's what I'll talk about now. So to start with, for this problem of data hoarding, right, where data is the new moat, it's not about the algorithms, it's actually about the data, right? Why would Google or Facebook or LinkedIn give up their data? But imagine if there's value, if you have 5 or 10 organizations in an ecosystem, they share their data. What are the benefits that can come out? So in the project called Genesis of Things, which is with Cognizant, with Innogy, with Intel and others, and we're a part of this too, there is the idea of, the problem is fraud with 3D printing. So if I design some CAD file with AutoCAD, and I go to have it manufactured in China or somewhere else, someone might copy that CAD file and then start printing on their own, right? This is really an issue. So imagine, though, that there's the ecosystem itself keeps track of all the different designs that are done by the different companies. So maybe 99% of the designs are done by 5 or 10 companies, or 50. Well, those companies, those 5 or 50 companies, all put their designs into one pool, and it can be properly private and so on too. But whenever a design gets manufactured, then if it is possibly using one of those designs, then an email gets sent to the possible rights holder saying, hey, this might be using what you have designed, right? So it's not blocking your design, it's just informing the rights holders that, hey, your thing is getting, your design, your CAD file is getting printed, right? And then from that, you can decide for yourself, hey, was this legit, was this not legit, and so on. But at least you have visibility into what's going on. So this is actually very, very useful because otherwise we could have flagrant stealing of IP, and it's expensive to design things, aircraft turbines, et cetera, right? So this is one example here where if you can actually pool the data, what's happening here, using decentralization technology and reverse 3D search basically, then you actually end up with a solution for the whole ecosystem. There's a similar example of this in the world of diamonds. We actually worked on this more than a year ago. In the world of diamonds, fraud is also a big issue. It's about 40% fraud in the world of diamonds. What that means is if someone is selling a diamond on eBay, they could claim something about that diamond that's completely wrong. They might have actually gotten it by ill means. It might be a blood diamond, one of these bad things. But imagine if you actually knew the whole provenance of the diamond, the whole story from the time that it was dug out of the ground, right? Then you could actually claim that it's a legitimate diamond. And if it was a cubic zirconium or something synthetic, that's okay too. You just know the story. So when you go to buy something off of eBay or whatever, then you just know where it comes from. And it turns out that the stuff coming out of the ground is actually certified by just about 5 diamond shops. That's it, certification houses. So what's happening now is these 5 houses are actually pooling their data together. And once you have that, then you can actually cross-reference the diamond that shows up in eBay with what is being pooled on from these 5 certification houses. And so basically, from that, once you pool, then you can start to see, is it fraudulent or not? But you have to ask, how do you check? And one of the checks, we actually built a model that predicts the price of a diamond based on its characteristics. And it's mostly the 4 Cs, which is the carats, the weight, the color, and a couple others. And with that, you can actually predict the price. And so if you see a diamond on eBay, that the price is radically different than what you predict, that's a yellow flag. That's saying, hey, maybe this diamond is fraudulent, right? And there are a whole bunch of other things that you can check for too. So any diamond showing up on eBay, it might have 10 or 20 yellow flags, and, or it might have 0. And if it has 0 yellow flags and 0 red flags, then you're probably okay. But if it has 1 red flag or several yellow flags, then you might worry a lot, right? So pooling data, once again, is very helpful here. Keeping going, what about monetizing your algorithms, right? So imagine you write some code, you design an algorithm, you manifest it, as code. Well, what about claiming that as IP? It's actually possible, right? It's an idea that's manifested. So just to show it as an example, where we started back in 2014, like Valentine mentioned, was with our first project was called Ascribe. So it's IP on the blockchain. So what I did was as an example to show here, I took a cart tree that I had done in the mid-2000s for analog circuit design, and I simply ascribed it. I claimed the copyright to it on the blockchain, not just this image, but also the ideas behind. And so then, basically, now I've claimed the copyright. I can then license that to others, right? In this case, I said there's 3 possible licensees, so there's scarcity. And if you want to buy this from me, you can come up afterwards, give me $5, and I'll transfer one of the licenses to you using blockchain under the hood, and all the proper legals, of course, too. So under the hood, this just takes care of it. So that's with Ascribe. Another example. So the problem of monetizing algorithms, right? So Numerai, many of you might know about it. It's pretty interesting. It's a hedge fund. But instead of 5 smart folks in a corner designing algorithms very quietly and secretively, what Numerai does is it's gathered together a community of more than 10,000 data scientists. Any one of them can submit an algorithm, and that algorithm then starts trading. And if the algorithm does well, then the data scientist does well, and Numerai gets their cut, right? But there was a problem, right? Let's say that Numerai makes $10,000 in a day. If my algorithm does the best, then I get a higher cut. But it also means that I wouldn't tell my buddies who are good at data science about Numerai, because it's a zero-sum game. So I'm not going to tell anyone. I'm not incentivized. But what Numerai did was they said, OK, let's tokenize. So let's say basically all the data scientists participating so far get a token based on participation so far. And this token you can buy and sell on crypto exchanges, just like Bitcoin and Ethereum. But now, if Numerai does well on any given day, then with my algorithm, for example, then not only do I win personally, but everyone else wins too in the ecosystem, because the value of Numerai goes up. Or their coin is called Numerare, actually. So basically what's happened is they have converted a zero-sum game to a positive-sum game via tokens. And the tokens align the interests of everyone in the ecosystem in an economic fashion. This is really a key point. So it's sort of taking the idea of decentralization, like I mentioned, as a benefit, and the idea of assets, and swirling them together towards this token, the alignment of incentives of the participants in an ecosystem. And that's a very powerful idea. And this core idea is one of the things that is driving all this ICO madness these days. Keeping going, what about if I've already secured my work on the blockchain, but it spreads online, right, and spreads everywhere? Wouldn't it be cool, wouldn't it be great to have visibility into what's going on? I could try to lock it up, classic DRM style, but that doesn't really benefit anyone. But what if I simply just have visibility into where my stuff went? So I had the example of 3D designs before for 3D parts, but you can, of course, also do this for images on the web. And this is actually, we did this in late 2015, called Where in the Net. So you can take an image. In this case, it's Doge, because, lovely little dog, and the godfather of the Doge coin. You can put it onto Where in the Net, and then it will tell you what is the number of copies versus time. And it starts, in 2014, it just started taking off. That's when Dogecoin was released. And now there's actually more than 2,500 copies of this. And each different color is a different website. So there's one website that really loves Doge. It's got more than 1,000 copies, right? So this is very useful because it gives this feeling of control back to the creators. And you can do this not just with your friendly neighborhood Doge, but you can do it with your company logo if you want to see how your popularity is growing. Or you can do it with your face if you're very vain, and so on, right? And so on. Keeping going back to the data problem, right? I mentioned this problem of garbage in, garbage out, weak data history. Well, what's really amazing, blockchain technology, you combine the immutability with decentralization, and this unlocks the idea of audit trails for data and learning, right? So basically, every single step of the modeling process and the deployment process, you could actually timestamp. So when you have your sensor and input stream data coming in, that can actually be stored decentralized. It can be timestamped into something like IPFS, the IPDB, interplanetary database. And then from that, you create your training XY data. You can timestamp that, store it decentralized if you want. Even the model building itself, you can be storing the convergence curves and all the artifacts from that. And now you have the model. Then when you deploy the model, once again, you've got your testing data come in, or your field data, the model simulation, and the testing data. Each one of these steps can be actually timestamped onto a blockchain database, a planetary database, and even stored if you want, right? So now you actually know the whole history of what's going on. If you find that you've got some terrible model performance, then you can go backwards and see what's going on. It's basically like FX reconciliation in the financial world, but here it's reconciliation for AI models and training. And this really matters. For example, in the world of self-driving cars, if a car crashes and kills someone, wouldn't it be nice to know exactly where things went wrong, right? And so this is an example. So keeping going, actually, let's talk about cars a bit. If you go to buy a used car at some used car lot, at least in Canada, there's this idea of a sleazy used car salesman. They're the most untrustworthy person in the world. They're going to lie however they can, even worse than statistics. They'll lie in order to sell you the car, worth more than it is, because he gets his percentage, his commission, or her. And so imagine, though, instead, you actually knew the whole history of the car. And that history isn't spread to the whole world, but they expose that history to you when you're looking at buying the car. So you might be able to see all the time, everywhere the car has driven, every oil change, the time of purchase, every owner, all of that, right? And it can actually be shared securely to you just in the moment of purchase or in the consideration. You can see what's going on. It can't be changed. And in this way, when you go to buy that car, you actually have a much better understanding of what's going on. So this is something that we're working on with Energy and with Volkswagen. in something called CarPass. And this is a prototype that we announced a couple months ago, basically. And you can see, actually, it's got some pretty interesting graphs. Every single entry there is another trip that's recorded, and then it kind of shows the trip that went on. And then you can also see, well, there's a bunch of interesting stats on top, right? So just with D3 and stuff like that. So that's basically an example of CarPass with provenance of vehicle data. And you can do data mining on this, of course, too. So there's a bit of statistics here, but of course you can build fancier models and fancier models. So another kind of interesting thing is when we do storage of large data sets or compute, it's pretty expensive, right? S3, they have their markup compared to if you're storing on your own hard drives. And EC2 is even more expensive. And if you're using one of the services like Google's service for TPUs and so on, these all cost money. What's interesting, there's markets now emerging for storage of the raw data blobs, data sets, as well as for compute. So for the storage, I've mentioned them briefly before, storage.io, Filecoin, and so on. These are basically driving the cost down of storage. So these things are often 1/10 the cost of storing in S3. Not only that, they're decentralized. So that's actually quite powerful, and they're just maturing now. Same thing with high performance compute. These ones aren't quite mature yet, but these are marketplaces of basically buying and selling compute. So in the past, you might have donated your compute time for like folding at home, but you're just donating, it's like a charity. Here, you're actually letting your compute time be used, but you're actually making money from it, right? And not just for mining Bitcoins where you would have no chance, but for actually whatever people want to do. Moving on, with data, there's this big challenge of data being expensive and really hard to price. So what's the ultimate way to unlock data? A data exchange, or a data marketplace, to be more precise. And why I say that, sometimes data is fungible. You can exchange 1 mile driven of self-driving car data for others, in some cases. But that said, 1 mile driven in a blizzard in Canada is worth more than 1 mile driven in sunny California. And it's not just because Canada's better, right? So anyway, well, that of course is my opinion. But anyway, so what we actually did, we worked with Toyota Research and others to build a prototype of a data exchange for self-driving car data. So their challenge actually that they have at Toyota, and most self-driving cars, it comes down to the unreasonable effectiveness of data. You can build a self-driving car algorithm with 10,000 miles driven, but you'll have an error rate of say 10%, right? So do you want 1 in 10 times the car drives it to crash or kill someone, right? It can't be 1 in 100. It needs to be 1 in a billion or on that range, right? It needs to be at least as safe as a human driving, and ideally 10x or more better, right? The problem is, to get there, Toyota and others have calculated that they need 500 billion to 1 trillion miles driven, right? That is a lot of resources. That's a lot of miles driven. So Toyota said, hey, why don't we work with other auto manufacturers doing self-driving data and others like Uber, et cetera, and pool our data together, and not just say, let's kumbaya and hug and everyone just share, but actually just charge each other a reasonable price, right? And that's basically what's going on here. So it's actually a data marketplace for self-driving car data. The prototype, we called it AVDEX, Autonomous Vehicle Data Exchange. And you can see, you can enter data sets, you can set a price, you can buy it. And also, we actually have some privacy preserving features with this stuff called zero knowledge proofs, which is basically sort of like Monte Carlo sampling on information for privacy. So these are basically some interesting examples of what's happening in the world of AI and blockchain together, how decentralization is actually helping AI. There's sort of another side twist as well. I'll be very quick here. AI DAOs, it's a really interesting symbiosis of how AI and blockchain work together. A DAO is a decentralized autonomous organization. It's basically code that can run around on the net, but it actually can own its own resources, right? It's got its own Bitcoin wallet, right? So a quick background, in the world of AI, there's actually been people doing creative AI for a long time. My friend Greg, for example, his day job was NASA, now Facebook, but his evening job for fun for many years was basically jewelry design. So he set up a shop called Orbimi, and it looks and feels like Amazon, but it shows all these designs, and every single one of these is automatically generated with a variant of genetic programming. And if you click on it, you click on any one of these necklaces, then it will come up with another 20 variants of that necklace. So it really is actually Earth's largest jewelry store. under the hood, there's billions of designs. And then when you like a design, you click it, and it basically 3D prints it and gets sent to you. So that's Orbimi. The point is, this is already 10, 15-year-old technology. So in the world of AI, this creative AI has been happening a long time. Myself, I did my PhD on creative AI of analog circuit design about 10 years ago. Moving on, though, and there's also, beyond creative AI, there's AGIs, and we probably all know this, but it's the idea of agents that can sense and model the world and act on that model of the world and repeat, repeat, repeat. And this could be like agents running around in Minecraft or something else, but it can also be something much more general. The very core of AlphaGo, for example, actually had a model of AGI as a control system. And that actually is a way that you can frame AGIs in this sort of control system standpoint. And then you get to leverage the math and the theory that goes back to Wiener in the 50s. So going then, what if you mix all this together, this idea of DAOs, decentralized autonomous organizations, with AI, with creative AI, in sort of this feedback loop fashion. And the example I give here is something that I call the art DAO. So here's the recipe. You've got this DAO running. It's running some script on decentralized substrate. And it generates some piece of art or some jewelry design automatically, using genetic programming or deep learning, whatever, generates this new image. Then it claims attribution on the blockchain, claims IP, whatever. It sells it on a marketplace. Could be on eBay or some decentralized marketplace like OpenBazaar. And then it sells those, right? So maybe it spent $1 worth of compute power to create this thing, but it sells it for 10, right? So it sells this thing. So there's basically money coming into it in exchange for the IP that it's created, right? And then basically you repeat, you repeat, repeat. So now it's got $10 instead of $1. It creates 10 new pieces of art, sells each one of those for $10. Now it's got $100. Rinse, repeat, rinse, repeat. $10 to 100 to 1,000. Keep going, you've got the world's first AI millionaire, right? Or even billionaire. And as a quick aside too, you might ask, yeah, but does it have any rights? Well, actually, there's rules in Switzerland. There's a town called Zug, Switzerland, where you can actually have a corporation where no flesh and blood humans need to be attached. What that means is you can actually take a corporation, you can automate it very simply DAO style, and then you can basically give it some of this AI knowledge. And it's basically given this AI rights, because corporations have rights, right? Corporations are people too. So AI DAOs basically are people too. So this AI DAO that we've created, it actually does have the same rights as a corporation because it literally is a corporation, right? So this is kind of a fun concept, and there's a whole bunch of things that fall out of this, right? And I've written and talked a lot more about this. So given that this is PyData, I thought I'd just take a few minutes very quickly and talk about deployment architectures. How can you, as Python experts, interested in AI and blockchain too, apply this yourselves, right? So there's a very, very simple architecture to start with. And this is simply only have storage that's decentralized. You can have a decentralized database where it's basically you're seeing database as a service, but there's no Amazon or Atlas or Mongo behind. It's just this decentralized website. So that is basically like IPDB. You can also have the decentralized file system, right? And this would be like IPFS, et cetera. But and in the front side, you just have JavaScript running in the browser, right? Or Swift running in iOS, et cetera. So deadly simple. And by the way, we've actually worked this out in practice many times. The example I gave before with the decentralized data exchange, it was actually using this architecture. And we already worked out things like identity, where you just pass in basically your private key as a brain wallet. It's sort of like a simple way to think about your private key. And it does all the identity stuff securely on the client side. And by the time it hits the database and so on, basically there's no storage of any identity things. So there's a very nice sharing back and forth. So a very, very simple architecture. You can get going. If you're a pure JavaScript developer, then this is perfect, right? It just feels like database as a service, S3, et cetera. But of course, if you want to start pulling in some heavy lifting from ML, then what you can do is create your own service, ML as a service, or someone else's, right, from Amazon or whatever. And then you've got this sort of mix of some decentralized on the left, including who owns what, and then some centralized ML as a service, all connected in a browser side and the client side, right? So this is also a very simple architecture overall, right? You just got a few services, all speaking HTTP to the JavaScript side. We can keep getting a bit heavier. So we can use the sort of mass compute side, where for storing large blobs of data, we can use Hadoop, S3, but also maybe IPFS. For database, we might have some stuff in MongoDB or something, as well as in the interplanetary database. For business logic, maybe just straight up EC2, and then leverage high performance compute like before, NVIDIA GPUs, et cetera. So in this case, everything basically stays centralized, except for the one thing that really matters, and that's who owns what. That is decentralized, and that's what goes into IPDB, okay? So this actually makes it easy to deploy blockchains and AI, because you can actually maintain your whole system, all of your software and so on, and all you're doing is plugging in to IPDB via the HTTP API. And of course, you can go full-blown into this whole idea of decentralize all the things. So this is in line with the stack that I talked about before. So, and in this case, oh, by the way, too, going back here, of course, you'd have Django or Flask or something, right? Some good Python backend. You can also, though, decentralize all the things. And in this case, decentralized file system, decentralized database, decentralize the business logic, and high-performance compute. And in this case, it's basically the same things as before. The high-performance compute, you would use something like VMs as assets. That's the more mature one, or maybe TrueBit, which is coming down the pipe. And there's even actually platforms like something Django-ish in the, at the higher level. And this is things like Monax or Block Apps. So there's basically this spectrum of things that you can do, from very, very simple to more and more full-blown decentralized, right? So with those stacks, and with what I've given you as some applications, right? How might you get going, right? And it's actually much simpler than you might think. You don't need to go and take a month-long course, a 2-month-long course from some purported blockchain expert who will charge you an arm and a leg. You just need to sit down and start coding. And the interfaces have gotten much simpler. And I'll use an example from my work simply because, well, I do it, and I think it's nice and simple. So you can actually go to beta.bigchaindb.com/get-started. This will get released. It won't be beta starting on Monday, but right now it's this. And you'll see, basically, it's got JavaScript, so this is the single-page web app as a demo. On the left, it says, let's write a message into a planetary blockchain database. So you type in a message. And then you click, off you go, right? And in this case, I just did this an hour ago and copied and pasted into my screen. I typed hello PyData. And then what it did was it took that message and it automatically, using the JavaScript driver in this case, it fleshed out JSON where hello PyData was a key message, and it sent that off to the interplanetary database. So this is basically the public database of BigchainDB. And this is the JSON that it's stored in there. And you can see that it's got a message called hello PyData, and also it's stored as an asset. And it says, nicely done, you've just created an asset, sent in a signal, and received the response. And if you want, you can click on it and see basically the Explorer to browse what else is on IPDB. And so this is just a demo in JavaScript, but if you want, then on the bottom left here, it's hard to see, but it shows you examples using curl, Python, and Node.js. And I will zoom in on what this looks like for Python. So in this case, it was just using the Node.js stuff, but if you want to do something in Python, it can be actually quite simple. So maybe you guys can see this, but maybe I'll just read out the key things. So for Python, there's a library up on PyPy for the driver. So, and it's called bigchaindb_driver. You import that as well as one of the key pair parts from the crypto library. And then there's just a few key steps. First of all, you create an instance, a driver-side instance of the database. So this is just the pointer to the database, of course. You point to a URL. In this case, it's IPDB. Then you generate a key pair, which is basically the public and private key. It's sort of your identity with your password, right? And then you create a transaction where you're just specifying the message, in this case, hello PyData. You're signing the message, and this is really a key thing, right? So signing a message is proving later on, then people can see that it truly was you that created that message. So you're signing it with your private key, right? And then you're pushing it to the network. So it's basically creating this JSON blob, signing it, and then sending it to the network. Very straightforward. And that's very similar to what you're doing in a normal database, where you create some JSON and you push it to the database, and the one extra step is just simply signing it, which is really key, right? So it's very straightforward. I encourage you guys to try it for yourself. So basically, in literally like 5 minutes, you can actually be creating data, putting it onto a blockchain, blockchain database. And it should be that simple. It is that simple if you think of it as a database. You don't need to go and become some blockchain expert. Just like to drive a car, you don't need to know the mechanics of internal combustion. And if someone tells you otherwise, they probably don't know what they're talking about. And there's a lot of those people in the blockchain world, by the way. So, because there's a lot of money, right? So, and of course, then, to bring in the AI, it's only one import away, right? Import sklearn or your other favorite ML library, the stuff maybe you've rolled yourself. And then you start building models, and you can store those in various ways on the database, et cetera, in some of the use cases I've talked about, right? So very straightforward. It's simple. It should be simple. Don't let anyone tell you otherwise. So to kind of wrap up my talk here, blockchains, it turns out, can really help AI. And the core of it is it's all about the data. It's about getting the data via pooling or via data exchanges, but also getting good data with provenance, solving the problem of garbage in, garbage out. And then there's this, pesky AI DAO thing, AI that can get rich, code that owns itself. There's a huge ways to extrapolate beyond just the simple art DAO that I talked about. And it's actually much easier to get started with AI and blockchain than any of you might have realized, right? It's just a couple imports away. And so with that, I will conclude and leave the floor to questions.
So do we have any questions from the audience? Also, we're running about 15 minutes late. So yeah, so the entire conference is running about 15 minutes late. You finished early, Trent. And so you have plenty of time to answer questions. So there should be some people with microphones. Please feel free to ask.
Thanks for the presentation, spectacular. One question about this kind of a year.
The mic isn't working.
Okay.
I can hear you. But I can hear you.
Okay. Now? Cool. Bravo for the presentation. I had one question about use of this kind of technology in an enterprise perspective, not just for fun. One of the things that we have to deal with in Europe is right to be forgotten, GDPR, et cetera. How does this kind of play with this type of technology?
That is a fantastic question. Right to be forgotten directly contradicts the idea of immutability, right? The answer is actually encryption of personal data. The laws are actually fuzzy on this. If I actually have my personal data, that maybe my birth date or something else, being stored, encrypted in some public network, right now the law doesn't actually have much to say. If it's encrypted, is it an issue, yes or no, right? So what's happening is we are actually working with the regulators here in Berlin for Germany as well as with the EU, giving very specific guidance on how to update the laws to account for the new technology, right? So, in fact, just last week, there was a big meeting of about a dozen different blockchain organizations with the German government on specific issues like this. So that's one of the issues. There's also takedowns, right? If someone puts up some, Disney Frozen or something up onto IPDB or IPFS, you can't take it down. So what do you do? And there's near-term answers too for this, and the near-term answers are de-indexing, just like, I can put something up on the web and no one can take my server down, especially if I'm not in Germany or something. But at least Google can de-index a search. So the main interfaces to this thing can actually be at least be made hard for the mainstream, right? And the third related thing in terms of regulations that's really important is these token launches that are happening, right? People call them ICOs. Is a token an asset or is it a security? If it's interpreted as a security, then you have massive security regulations, especially in the USA. If it's an asset, it's much simpler, but the law has been unclear so far, except for Switzerland and Singapore where it's become very clear. So that's why most of the token launches are out of there. But going back to your original question, right to be forgotten, it's a big issue. Fortunately, there are clean solutions, but it does involve working with the regulators. And kind of related to that too, just as an addition, this isn't your grandma's blockchain anymore, right? As in like Bitcoin, it was all about sort of like, let's tear down the existing institutions and break it all and let's kill the banks and it's anarchy and free for all, full libertarian. That's a cool, inspiring idea, but my view is you actually have to build bridges to existing society. You have to work with the laws and with the mainstream and see what you can do with this new technology and make the world a better place from within, right? Sure, you can have revolutionary ideas, but it's about building a bridge. So in the case of the right to be forgotten then, it's actually about working with the regulators. And it's kind of amazing. They're surprisingly receptive. Maybe I shouldn't have been surprised. This really matters, and they're actually reconciling with the law.
All right, any more questions?
Yes.
Any more questions?
There was a question just about the right to be forgotten. Another thing is when you actually lose key, right? Private key, it's gone forever, right?
Yeah, yeah.
And
So there's actually different answers to that. It gets pretty complicated, but it's interesting. When we first built Ascribe, which was the IP in the blockchain, we made it super simple, right? Like you can go to ascribe.io, sign up, enter your email, choose a password, and then people would use it, claiming stuff. And then they would email us. They'd say, hey, I forgot my password. And we'd say, you're screwed. And actually, I mean, that's how it works. Like with Bitcoin, you lose your coins and so on, right? So then we started asking, well, how do we solve this? And one of the answers is multisig. So basically, imagine there's multisig means, let's say, 2 of 3 passwords or private keys to unlock any given thing. So it could be you have 1 private key, and then the company, like Ascribe, has 1 private key, or BigchainDB, and then there's 1 private key held by some third party, trusted third party, okay? And then if you lose your password, you contact that trusted third party, and then you also contact us, and we all agree, and we unlock that key. That's one way. There's also social unlocking. This is something that Uport is moving towards. So you your social network around you collectively helps you unlock, kind of you proving that you're you. In the case of Ascribe, what we did, it was simpler. Because it was just about provenance of ownership and so on, we had it saying, if you get a key, you can get a password reset, a key reset, and we just would timestamp into the blockchain that you got a key reset. Now, of course, this is where you're just doing timestamping. It's not as good for transfers of value, but when it's timestamping, it's okay. So, of course, it's slightly less trustworthy because if it's showing that you got a key reset, like a new set key pair, then what if someone else stole? So every time you do that, it compromises the trust a bit more, a bit more. There are also hardware wallets that people often carry. So just like you have a contract that says you own a particular house, you can have a USB stick that has all your private keys. And this is actually becoming a pretty big thing too.
Yeah, sure. And also, I would like to ask about the integration of standard traditional ledgers with, crypto ledgers. Because really, you just mentioned interledger protocol, right? But basically, if you have a memory of someone giving something to someone else in human brain or in some other database, for example, an email, email messages and so on, this information is not accounted for. Actually, you can't, only the blockchains matter. Is there some kind of layer that would integrate the blockchain world with the traditional world?
Yeah, so this is once again all about building bridges, right? So
yes.
Often people like to claim, blockchains are a single shared source of truth. That's absolutely wrong. They're not truth machines, they are claim machines. So when people make claims, that gets etched in the stone basically. But it's what are the claims that you make, and other people can make claims in your claims and so on. So this is part of the key towards building to the traditional world. Then you can say, okay, well, what are the ways that these things make sense to work together? And this is all about the stack that I was showing, right? So you can actually have your traditional stack in the cloud or whatever, and add in another database, a blockchain database. Also, with BigchainDB itself, when we went to build this blockchain database, we said, what are some great pieces of technology that we can leverage? So we actually wrap MongoDB. Like, we didn't have to do all this amazing, it's a really heavy lift to do sharding well. It's a really heavy lift to do low latency queries well. So we didn't bother ourselves. We took advantage of the great work that the MongoDB guys did. And we also wrap Rethink. Yeah.
One other question. Can I?
I'm afraid we're kind of running a bit late now. It's
very related to
11:41,
artificial intelligence.
And I'd suggest you hook up with Trent immediately after the talk.
Okay, thanks.
Great, let's thank the speaker once again.